having downloaded the data set, I'm going to come over here to File. So I'm coming over to File on the top left, and I'm going to click OpenDB. And then what is really cool about this online site is that it lets me upload data sets. So I'm going to search my computer for Chinook because I've downloaded it a million times. I know I've got it somewhere. So chinook.db. And there we are, chinook.db. So I am now going to upload it. Okay, so I have now successfully uploaded chinook.db, and I have our example. So the same example that I have over here on this data set is now available over here on our online example. And if you've fallen behind, I'll just repeat for one more second. So I can click over here. It takes me to the online demo. A little bit further down in the online demo, it lets me download it. I can click download over here. After I download, I go to SQLite Online. There's SQLiteOnline.com for our demo version of SQLite. The company is very nice to us. They give us a little online workspace. And on this online workspace, I'm going to click on File, OpenDB, and then I can upload. And now I actually have our database. So let's look at a couple of tables. Let's look at the table albums. So I will select everything, wildcard, from albums. And I'll hit Shift-Enter to give that a run. I have misspelled albums. I wrote albums, but I'll fix that. There we are. There's our albums. And I have, oh, look at that. It keeps a record of my mistakes. Huh. And I can't delete them. It's like real life. Okay, so there's a record of your previous queries. And anyway, so we have SQL and from albums, and there we are. And let's do this again. I'll just, I'll select everything, I'll delete, and this time I will select from artists. So select star from artists. Okay, and we can see that both of them have artist ID. So what I'm going to do is I'm going to select star from artists, and then I am going to give me 1 second. I want to look at our relationship diagram. Sorry, I've got two topics at the same time. All right, so okay, so let's continue, and then I'll make it all come together. So we're going to select from artists, and now we're going to put another table onto this. So we're going to select star from artists. Which one? Give me. And then we will left join the albums, and we will do that on albums.artistid, and have that equal to artists.artistid. Okay, so we have our query. We're grabbing from artists. We are left joining albums, and we are doing this on albums, artist ID, and artists. So that is going to be our key fields in both columns. And so when we run this, we get both of them. And so there is everything all at once. Now, there's something else that I want to explain. So let me take a step back. So hopefully this is a nice example. Let's do it one more time to make sure we're all together, and then I will talk more about this. I'll take us one step forward to make this come together. So I'm going to Command A, delete. I'm just going to pretty much retype the whole thing. So I will select star from artists, and I will left join albums on albums.artist ID, and I could use the little GUI here, and I hit the enter button to make it run, and then equal artists, enter dot artist ID, enter. It sort of it codes itself a little bit. That's convenient. Okay, so now that we got this up and running, let's take a step back and I want to describe one more thing. And then you'll also see why I got confused, because I'm trying to show two things at the same time. Here is our display. We see the tables, but you'll notice that there was more to this table. There were also all of these little connecting strings, all these connecting arrows. And that is what creates that's what describes the relationships between the table. And the tables are entities. And this display that we are looking at is called an entity resource diagram, ERD. And it shows how the entities relate to each other. So what's happening here between our artists and our albums is that every artist is a unique artist. And that's what this means: one, at least one, and at most one. So this two dashes mean at least one, at most one. And it's going to map to none or many albums. So I'm an artist and I'm trying to be a great singer, but I'm a terrible singer. So I have 0 albums. But I exist, so you can't take that away from me. So no matter what, there's at least one of me, because I'm existing. Here I am being just being. So there's one of me, and I can have none or many albums as I try to launch my music career. And so that is the relationship between these entities of artists and albums. So for one artist, and only at most one artist, so every album gets one artist at a time. So if we're a band, we're probably going to be considered one artist together. So a band gets only one artist name. So there's a minimum one and at most one artist, going to a minimum of 0 and at most a whole bunch of albums. And then an album can have music tracks. And so you can have tracks of music, and you can have no music and no album. So in a sense, they could both not exist. But at most, you're going to be in one album. So a track of music is not going to show up in many albums in this data set. I suppose in reality, you could have music show up in another albums. Let's do another one. So over here, we have customers. And our customer field is a key field. So this key means that there's only one customer. So the entry is only stated once. And I mean, imagine you were in a data set twice, you might get double billed. That wouldn't be fun. So your customers are entered once. And now for one and only one customer, you can get an invoice, you get a bill, and you get 0 bills or many. Now, if you haven't ordered anything, you really don't want to get a bill. So you can definitely have 0 bills, but you can also have up to many. So we have from 0 to many bills. And then if a bill exists, then there's one and only one of it. We won't double bill. And then that goes to the items that are on the bill. And maybe there's no items on the bill, which would be kind of weird, but maybe it's just a statement. Maybe it's just a statement without items, or maybe it's a weird degenerate case. But from our invoice, we can have no items on it or many items on it. So someone bought this music album and that music album and this music album and that music album. So people can have purchased many things or purchased nothing So we have invoices, and the items can go from 0 to many. And that's the game. And the game does get a little bit more complicated, but I think that's a good point. That's a good point to stop on it. So what we can do now is we can explore this in terms of artists and albums, because we've already done it once. We have already once done a join between artists and albums, and we could do it on artist ID. But there's going to be a difference between left joining from artists to albums, where there's one and only one artist going to an album, and that seems to be the right way to do it. We have our key field of artists, so we have a unique artist. On the other hand, it's possible, at least mechanically it's possible, to join from albums to artists. But when we do that, it's going to be messy, because we're going to be taking the repeated artist display and adding the artist name to it. Okay, so let's see what that's like. So I'm going to now come back to our code. Here we are, and I'll just start fresh. So starting fresh. So let's select everything from our artist table. So from artists, and we're going to do it right. So the first time we'll do it right. We will left join and artists, and we're going to join on artists dot artist ID is equal to albums dot artist ID. And I've made a mistake. I should have, I'm already in artist. I want to join on albums. Let me change that to albums. Okay, so here we are. I have my artists, and I am left joining albums. And I think I've done that. And now when I scroll down, and I eventually get to, I have 275 entries. Okay, so there are our entries. I have 275 entries. We could see it by artist ID. And I also have other fields that I don't really need. So what I can do is I come over here to select, and I can clean this up a little bit. So I will select artist ID and name, and the data that we're getting from the albums, which is the title. Okay, and now I'll run it. An artist ID. Artist ID is repeated. We see that there's one over here and another over here in our album table. And so apparently AC/DC, the band, made two titles, Let There Be Rock and For Those About to Rock, We Salute You. Great names. So, but it appears twice. So our artist ID is appearing. We have artist ID here and artist ID here. So let's instead have this be artists.artist ID. Okay. And now there we are. And okay, so that is one query, and it is forever over here. Let me make another query, and I'm going to move. So I hit the little plus button over here, and now I've just got a fresh table. So a totally fresh table. And let me see if I can get the count. So select the count of, it doesn't matter the field, name from artists. Okay, so there are 275 unique records. Great. Okay, now let's come back to our entity resource diagram. This is the big subtlety. So in a sense, I really have two major things to communicate to you today. One is over here, the big syntax, and we're working through that now. We're selecting from a table, we're joining on another table, and we join on a key field. Cool, that's fine. That's one major lesson for today, the basic syntax, getting up and running. The other thing is the impact of joining based upon how the data was organized. So here is our entity resource diagram, and we see here that we have the 1 by 1 to mapped to 0 to many. And that's why we're joining from artists to albums. And if we join from albums to artists, we're going to get a very different display. So going from artist to album gives us one sort of unique display that's by artists, and the other direction will get us a display that's by albums. So let me now come back over here, and now I will hit Command A, I'll delete that, and I will do this in the opposite direction, merging from the album table onto the artist. So I will select star from albums, left join artists on, the order here doesn't matter, artist.artist ID equals albums.artist ID. Okay, and notice how quickly I can do it when I use the autocomplete. That's nice and convenient. So now I'll run this, and this time, I don't know if it shows, but we're going to have many more fields. So if you could look at the album ID column, and using this album ID, we've made it up to 347 displays, because this time for all of the albums, we have a display, we've pulled it over. And both of these are correct in terms of the if I was to only display the name from the album, I'm sorry, the name from the artist name and the album title. If I was to only show these two fields, then this would not be the right way to do it, because I'm going to have repeats. I'm going to show the same thing a few times, and that's not great. So so instead, I might want to do it the other way, the original way, the first way we did it, where I go from the unique artist over to the album. Okay, so let's. So now that we have that idea, so one more time, one last little emphasis on that idea, right? We have our relationships over here, and it really shows about what you want to talk about. If I want to talk about the artists, I should bring the albums onto the artist and not repeat the artist. But if I want to capture all the albums, then I would start with the album and grab onto the artist, and I would be repeated in artists, but I would have a complete display of all the albums. And maybe that's okay, because some albums are going to have artists twice. So this is much easier when it's your subject matter. And once again, this sort of comes back to the difference between a professional database administrator and someone that wants to do their work. We can cheat by really knowing our subject matter. So in this case, by knowing about music, we can make it very easy on our brain to go, oh, of course. Well, if we want to talk, every musical artist can have many albums. If we want to see the world of albums, we'll need to get the albums and then pull the artists on. And we might repeat the artist because one artist can have done many albums. So we would need to start with albums and pull the artists onto it. And that will get us a large data set. On the other hand, if we want to focus on the artists and just see about them and pull one album on, we can merge by artist and then show the album. So that's the world. And in fact, here's a display, right? Here's our artist getting shown twice, and there is our two different names for the music title. Okay. Now, what that brings us to is one last little display together. Our last display is to practice this a little bit more. So give me 1 second to organize my screen, and I'll take us through some drills, and we'll just build our familiarity with the language. So we'll just drill for a little while, practice more and more syntax, and then that will be our intro to SQL. Just give me 1 second to stop my sharing, and then I will share again. And nope, sorry, still working on it. 1 second. Okay, great. So hopefully right now I am successfully sharing my online SQLite page. Let me know if that's not the case, and I'm clearing this out. And all right, so I now have a whole list of little ideas to share with you, and we can practice together. We can type these up. It'll help us remember everything, and that'll be good drilling. So one thing we could do is we can also do some math operations, and I'm going to come back very quickly to our Chinook data set, but just one more little point. I can select 1 plus 1 and give that a run, and there we are, we have 2. And so math operations are possible, and we'll see more elaborate things a little later. Okay, so other things. We can use the wildcard. We've seen that already. We can also select things in order. So from the musical tracks field in our data set, I'm going to select 3 fields: name, milliseconds, and album, and I'm going to order them. And that way we'll be able to see the order by album ID and by maybe the time. So once again, coming, I can't, give me, okay, so I can't go back to the, yes, I can. Give me 1 second to just get the page from us. Okay, I'm back, and I'm going to come over here. And in 1 second, there we are. So we're going to work on the tracks table. So here's our tracks, and we're going to grab milliseconds and name and album ID, and then we're going to sort. And we sort using the order by command. So you can write order by and then put the field that you want. So let's look at what that'll look like. So I'm going to select, and then I can actually come over here and I can tab over. I could type name, milliseconds, and album ID. And I'll hit delete, come back from, and I can come over here, the tracks table. And let's give that a run just to make sure I haven't made any mistakes. Okay, so I ran that just to make sure that's all going well. And now I'm going to continue. So I'm going to hit return, and I will order, and it's order by, so I have to have that by, and I order by, let's order it by milliseconds. and I'll give this a run with shift return. And there is our result. So I have, and we can see how we are increasing in milliseconds. I can also go in the opposite direction. I could go descending by after the word, after what I want to order by, I type in descending. And now we start with the largest tracks first. Okay, so that was order. And there's one more thing that we can do. We can order by column number. So sometimes that becomes very easy, especially if you've been naming things or you've been making up a field name. So milliseconds is the second thing that I've grabbed. So I could just put the number 2 here. So now I'm ordering by the second one, and I'll give this a run, and we got the same result. Now notice something dangerous. If I shuffle my query, so here's an operational risk, right? If I shuffle and I put album ID over here, and now I do it this way, it's going to now have this ordered by album ID in descending order. So there's 347, 346, 345. So using the number makes you at risk of having a logical error if the order of the fields you're querying gets shuffled. Okay, so let's look at another one. So let's also grab from tracks. This time we're going to grab track ID, name, and composer, and we'll order by composer. And we're going to see that nulls are going to come out, meaning that there's values. Missing data is just a fact of life, and it's even a fact of life in databases. So we'll see nulls, and then we'll see how the sorting treats the nulls. It's going to put them at the top, and that's just something to know about. So let's give that a go. So track ID, name, and composer. So this time, track ID, name, and composer. All right, I've changed my fields. I'm still grabbing from tracks, but this time I'm going to order by composer. And I'll give this a run. And we see that at the very top are all of the nulls. And then eventually, I hope, we're going to find some good, there we are. So so now in alphabetical order, we've reached the composers. Now, something we can do is we can put the nulls at the end. So I can order by composer, and after that, I could type in nulls last. And now I still have this in alphabetical by composer, but we get to see a nice display. This is really convenient because when you get the nulls at the top, you just can't tell what's happening. And you can't tell if you've made a mistake. So it feels very rewarding to always get a result when you run a query. And so if you do this nulls last, then in general, the nulls are going to be at the back. And so if I just drag this down to the end, there's all of our annoying nulls. Now they're at the back. So that's nulls last, adding to your order by query. Okay, what other tricks do I have to offer? The other thing that we can do is we can select distinct. So sometimes we just want to see what's available, and there can be repeats of things. So we can, let's hit Control A, and this time we're going to select from customers. From the customers, all the Chinook database. The database has many tables. One of the tables is the customers table. And this time we're going to select the cities, and we're going to sort them. And let's take a look at that, and then we're going to try the distinct command, because we're going to see that we have repetitions. So I will select city from customers, and I will order by city. All right, so there are our cities, and there's a repeat, Mountain View and Mountain View. And there's Paris showing up a couple of times. And there's Sao Paulo. Okay. And let's, I'm curious about something. Let me see if this, let me get the count. So I have 59 cities. And then I wonder if the distinct is going to, oh, look at that, look at that. So I have 53 cities, but I have 59 instances of data inside the field city because there are repeats. And then if I wanted to display the repeats, I can, if I wanted to not display the repeats, I can use distinct. Now notice something else here. If I run this, I think it's going to break. I mean, I expect it to break because the column is now going to be called distinct city. And I am ordering by city. So instead, if I order by the first result, I don't have to worry about the naming changing. Okay, so I'll describe that all again. So there we are. So we began, well, totally from the beginning. We began with select city from our customers data set. And we could just do that. And then we could order it. So I'd come over here and do order by city. And now I have the same thing, but in alphabetical order. But there's going to be repetitions. So I can change this to distinct city. And then I could try to run it, but it's going to, oh, that's nice. Okay, never mind. So this was pretty cool. It automatically named the field city, and then it didn't give me an error. So if I notice how if I don't, oh, okay, never mind. So the distinct command leaves the name city so it doesn't break. So I can still order this by city. Now, there are times when you do things more complicated and this name changes the name. So I did distinct city and it left it city. So when I do order by city, nothing broke and it was all great. If I wanted more flexibility, I could just put 1 here. And then if I change this to be more complicated, it'll still work. So I'll see if I come up with an example of that for us. But let me keep on working through my set of examples that I have prepared for us. So there is our there is the distinct command, and give me 1 second to think out my next little example for us. The other thing that we can do is we can have conditions. So I can select from city, and then based upon another field, I can work my logic. So let's go back to the tracks data set. So this will be much easier for me to think of in terms of milliseconds and tracks. So we're going to go back to the tracks data set, and this time we're going to select from tracks that have more than a certain number of milliseconds. So let me clear this out. I will select name and milliseconds from tracks. And now we're going to, all right, so let's just show that. That's nice and easy. Oh, and by the way, this is how I always do it. Yeah, I always, run it as you go if it's a small data set, which reminds me, I could have limit 10, right? So now, no matter how large the data set, I can practice doing things and not worry about taking time. So now I can come, well, now that I have that limit 10, I can just show all the fields and know that I'm not slowing down my computer unless there's a lot of fields. That's something to consider too. And I have composer, I have milliseconds. In fact, let's toss some of these in. So I can have composer and milliseconds and bytes and unit price. Okay, great. So now I've just grabbed those fields. And now I am going to grab from tracks where, and I'm going to have my milliseconds are greater than 2, 5, okay, greater than 2.5 million. So there we are. So I've shown the first 10 results where my my milliseconds are greater than 2.5 million. And notice how I also have bytes. So what I could do is I could, below where, I could have and bytes greater than, oops, hold on. 4,000,000,000,000. Nope, too many O's. Aha, so it looks like there were 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So I don't know if you want to repeat the bytes example with 8 zeros, but what I've shown now is I've conditioned with 2 conditions. So we have selected, and we have selected on a condition and another condition. Okay, and we could add more. We could have where the, so let's keep on going. And composer is like, and then inside a single quotation mark, we will have Smith. This may be too many conditions. Okay, so at this point, I've done so many conditions, we're not finding anything. Let me focus on just this composer example. So let me delete all of our work. It's kind of sad to see it go. In fact, I'm going to keep it. I'm going to hit Command A and copy this, and I'm going to make a new query. All right, so now in my new query, I'm going to modify this. I'm going to, all right, so I've deleted all the other conditions, and now my composer is like Smith, and I'm getting 10 of them. So, but it's not working. I'm doing something wrong, so I'll need 1 second to figure out what I'm doing wrong, and if I don't find it, I'll have to give up. So select, I got my composer, and I'm in the tracks data set. All right, hold on. Let me make sure. Okay, so there's our composer. And now from my composer, I'll have where, and I'll have composer, and I will have like. All right, so far so good. And now I've just got to get a little condition in there. So Smith. Aha, we got it. I don't know what I did the first time. I think I used star. Sorry, my mistake. Okay, so it's not star, it's %sign. I must have just been thinking of the wild card. So in this context, we use the %sign, and now we get to have everything that resembles Smith. So we have all these fields. You can see that there's Smith all over the place. Okay, so that was using like to get similar type fields. And let's continue playing with this just to see different things we could do. So I can have the Smith. Let me replace this with B R. Okay, so I have Brown, and in this case, I was able to leave the center kind of variable. And aha, there's Brian. So it wasn't a good example when I just skipped the O, but now I have two spaces. And now I also have Brian, and I have Brown. And maybe we'll find even more possibilities to find things with three spaces that start with well, that might have been, oh, there we are, Osborne. So Osborne also works. So it was B space 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 N. So Osborne was able to work. So each of these spaces is a space. And okay, and the other thing you could do is you can also find null values, and realistic. It's actually a little less exciting. This was actually more fun, but sometimes you have to figure out why your data is not working. So what you could do is you could say composer is null, and that's how you retrieve all the null examples. And those are the main ideas that I had to present. Now, one more thing. This example that I gave to you, there is this whole thing, this data set comes with a tutorial, and everything I've been showing you is making this tutorial come to life. And so you don't have to memorize everything that we've done. Hopefully, by typing it up, you've made some of this come to life. You've had a first encounter with it. You know how easy it is to go online. Whenever you want, you can now bring your SQL knowledge. You could start going down this road. You just come to this website. You use the online practice database. You don't have to download anything, and you can come to this tutorial with this practice data set. And then they even have start here, and I think this is going to show. It's going to take you to the tutorial. So the start here almost starts too soon. It's the tutorial where you get the value, and here it's going to start running through all of these commands. And so you have access to all of these commands. Maybe not shown the way I show you. I tried to like grab the most popular stuff. Unfortunately, you might have to do a more comprehensive approach if you work through the tutorial. But basically, in one day, it would be a long day, but in one day you would be up and running and be ready to do the kinds of things that you would do at the workplace. Yes, so that is our main website, and I think, oh, okay. The couple of other things I want to mention. One is that for those of you that took our dplyr class, our R class in dplyr, there was something fundamental about filter, select, arrange, mutate, summarize. When we studied dplyr together, I say, remember these because they're the things you can do. And what we are seeing right now that in SQL, once again, those are the things you could do. You could filter for different conditions. You can select the columns you want. You can arrange, you could sort them. You can mutate, you can rename them, give them aliases and stuff like that. And you can summarize them, like when I did the count. And for you can practice all of those and think in terms of those. The other thing to note is that you can run these commands from programming languages. And let me check. What I'll do is I will add some examples into our seminar guide where you call SQL from Python and from R. So I don't think that's in there, but I will add it in, and you can have that too. So I will add that to our seminar guide just to show how to run SQL from R and from Python, and once you could do that, you're in that second bucket of professional workplaces that use databases and programming language instead of Excel and networks. So anyway, I hope this gave you a strong start and lets you jump into the world of SQL database queries and operations. I will leave you to your weekend, and thanks for your time. This is our last seminar for the season. If there's anything you want to repeat again, we're going to start this all up in 3 weeks from now, 3 or 4 weeks from now, where we will start off again with Excel and work through the whole sequence. And so, and every time I do this, I try to add little ideas and more material and grow the seminar guide. So if you have ideas and suggestions, definitely send them my way. And that's it. Have a great weekend, everybody. Bye-bye.
Thank you. Have a nice day.
Thank you.